If you've ever flown on a commercial airliner, you owe something to a plane that terrified its own designers, the Douglas DC-3. When it first rolled out in 1935, engineers at Douglas Aircraft looked at the blueprints and saw a disaster waiting to happen. The wings were too thin, the fuselage was too wide. The whole thing looked like it would snap in half the first time it hit turbulence. Donald Douglas himself had doubts. His team had just finished the DC-2, which was already pushing the limits of what metal aircraft could do. Now, American Airlines wanted something bigger. They wanted 21 seats instead of 14. They wanted sleeping berths for overnight flights. They wanted luxury in the sky. And they wanted it to make money. The problem was physics. Every airline wanted more passengers, but aircraft design in the 1930s was brutal. Add more weight, and you needed bigger engines. Bigger engines meant more fuel. More fuel meant more weight. It was a vicious cycle that had killed plenty of aircraft programs before they ever left the drawing board. Douglas's chief engineer told him it couldn't be done safely. The stresses on the airframe would be too great. Metal fatigue would set in faster than anyone could predict. One executive at Douglas called the early designs a flying coffin waiting for a crash. But American Airlines was persistent. They offered Douglas a deal he couldn't refuse, a launch order for 20 aircraft if he could make it work. So Douglas took the gamble. His team went back to the drafting tables and started over. They used a new aluminum alloy that was stronger but still lightweight. They redesigned the wing structure 3 times. They added reinforcements in places no one had thought to reinforce before. By December 1935, the prototype was ready. It was called the Douglas Sleeper Transport, or DST. Nobody knew if it would survive its first flight, but on December 17, 1935, exactly 32 years after the Wright brothers' first flight, it took off from Cloverfield in Santa Monica. The test pilot that day was Carl Cover. He'd flown dozens of experimental aircraft before, but he later said the DST made him nervous. The plane was heavier than anything Douglas had built. It sat lower to the ground because of the wider fuselage. When Cover pushed the throttles forward and felt the plane accelerate down the runway, he half expected something to give way. It didn't. The DST lifted off smoothly. Cover took it up to 8,000 feet and put it through basic maneuvers. Turns, climbs, descents. Everything felt stable. Almost too stable. He radioed down to Douglas and said, "This thing flies like it's on rails." That was the first hint that maybe, just maybe, the engineers had gotten it right. But one successful test flight wasn't enough. Douglas knew that. So did the engineers who'd spent months arguing over stress calculations and load factors. Over the next few months, the DST went through punishing tests. They flew it in thunderstorms. They loaded it beyond its rated capacity. They intentionally stalled it at high altitude to see how it recovered. Every time, the plane held together. What really surprised everyone was how smooth it was. Passengers on test flights reported barely feeling any vibration. The ride was quieter than the DC-2. The cabin was spacious enough that people could actually stand up and walk around, which was unheard of in 1935. American Airlines executives who'd been skeptical started to see the potential. By mid-1936, the DST was certified for passenger service. American Airlines immediately put it on their premier route, the overnight service from New York to Los Angeles. They called it the flagship fleet. The planes had 14 sleeping berths and a small galley for hot meals. It was the most luxurious way to fly in America. But Douglas wasn't done. They realized they could strip out the sleeping berths, add regular seats, and carry 21 passengers during daytime flights. This version was called the DC-3. It was faster to turn, Meech said. Around, cheaper to operate, and airlines loved it. Within months, orders started pouring in from carriers all over the world. Even as the DC-3 started entering service, plenty of aviation engineers remained unconvinced. The aircraft industry in the 1930s was littered with planes that flew fine for a few months, then started falling apart. Metal fatigue was poorly understood. Stress analysis was more art than science. Nobody really knew how long an aluminum airframe could last under constant pressures. The DC-3's design made some engineers particularly nervous. The wings used a cantilever design, meaning they had no external struts or bracing. Everything holding the wing together was internal. If those internal structures failed, the wing would just fold up. Some engineers ran calculations showing that after 500 or 600 flights, micro cracks in the wing spars could become catastrophic. There was also the issue of the tail. The DC-3 had a relatively small vertical stabilizer compared to its fuselage size. Critics said it would be unstable in crosswinds or during engine-out situations. One British aeronautical engineer wrote in a 1936 journal that the DC-3 had all the directional stability of a weather vane in a hurricane. Then there was the landing gear. It retracted into the engine nacelles, which was clever for reducing drag, but it also meant more moving parts, more hydraulic lines, more things that could go wrong. Early DC-3 pilots reported occasional gear problems. A few planes landed with one wheel stuck up, causing minor damage. Critics pointed to these incidents as proof that the design was fundamentally flawed. Insurance companies weren't thrilled either. They charged airlines higher premiums for DC-3 flights compared to older, proven aircraft like the Boeing 247. Lloyd's of London initially refused to insure some DC-3 routes, calling them excessively risky ventures. Airlines had to put up additional collateral just to get coverage. What nobody expected was how wrong all these predictions would turn out to be. The DC-3 didn't start falling apart after 6-hour flights. It kept flying and flying and flying. By 1938, DC-3s were logging thousands of flight hours without major structural issues. The doom and gloom engineers started to look pretty foolish. In October 1937, a United Airlines DC-3 crashed near Cheyenne, Wyoming, killing all 7 people on board. It was the first fatal accident involving a DC-3 in passenger service, and it immediately made headlines. Investigators from the Bureau of Air Commerce descended on the crash site. Critics of the aircraft saw their moment. "We told you so," they said. The plane was too complex, too fragile, too dangerous. But when investigators sifted through the wreckage, they found something unexpected. The crash wasn't caused by structural failure. It wasn't wing fatigue or a design flaw. It was ice. The plane had flown into a severe icing condition, and ice had built up on the wings and tail, destroying lift and adding weight. The pilot lost control. The DC-3's airframe itself had held together perfectly, even through the impact. This was actually a turning point. Instead of condemning the plane, investigators praised its structural integrity. They noted that many older aircraft would have disintegrated in midair under the same icing conditions. The DC-3 stayed in one piece all the way to the ground. That told engineers something important. The design was even tougher than they'd calculated. More accidents followed over the next few years because that's what happens when you have hundreds of planes flying millions of miles. But almost every investigation revealed the same pattern: pilot error, weather, engine failure, sometimes sabotage, but rarely, almost never, structural failure. The DC-3's airframe just kept holding together. By 1939, the DC-3 had the best safety record of any commercial airliner in service. Airlines that had been cautious about adopting it were now scrambling to buy more. Passengers specifically requested DC-3 flights because they felt safer. Insurance premiums started dropping. Lloyd's of London reversed its position and started offering standard rates. The plane that was supposed to be a death trap was becoming the safest way to fly. Engineers who'd criticized it were quietly revising their papers. Douglas Aircraft couldn't build them fast enough to meet demand. By 1939, the DC-3 wasn't just popular, it was dominant. About 75% of all commercial airline traffic in the United States flew on DC-3s. If you flew anywhere in America, you were probably on one. Airlines loved it because it was the first plane that could actually make money. Before the DC-3, most airlines lost money on passenger flights and relied on mail contracts to survive. The economics were simple. The DC-3 could carry 21 passengers, which was enough to cover operating costs and turn a profit, even without mail revenue. It was also reliable. Maintenance was straightforward. Mechanics could swap out engines in a few hours. Parts were standardized. Everything about it was designed to keep the plane in the air making money instead of sitting in a hangar. Airlines around the world noticed. KLM in the Netherlands bought DC-3s. Air France bought them. Swissair, LOT, Polish Airlines, CLS in Czechoslovakia, everyone wanted them. By 1940, DC-3s were flying routes across Europe, Asia, Africa, and South America. It became the first truly global airliner. What really set the DC-3 apart was how forgiving it was. Pilots loved flying it because it was stable and predictable. It could take off from short runways. It could handle rough weather. It didn't require a co-pilot, though most airlines used one anyway for safety. One pilot in Australia said the DC-3 flew itself better than most pilots could fly it. Passengers loved it too. The cabin was pressurized, sort of. Well, not really, but it flew low enough that you didn't need oxygen. It was quieter than anything else in the air. The seats were comfortable. You could actually read a book without your teeth rattling from vibration. For the first time, flying felt like a civilized way to travel instead of a terrifying ordeal. Douglas Aircraft ramped up production. They built a factory in Santa Monica that could turn out multiple DC-3s per week. By 1941, they delivered over 4 aircraft to airlines worldwide. Each one logged tens of thousands of miles. The wings weren't falling off. The fuselage wasn't cracking. The tail wasn't coming apart. All those dire predictions from engineers, none of them came true. Then everything changed. On December 7, 1941, Japan attacked Pearl Harbor. The United States entered World War II. Suddenly, the military needed transport aircraft, lots of them. They looked at what was already in production and the working. The answer was obvious, the DC-3. The U.S. Army Air Forces designated it the C-47 Skytrain. The Navy called it the R-4D, but everyone called it the Dakota, or just the Goonie Bird. Douglas retooled their factories for military production. They strengthened the floor to carry cargo. They added a large cargo door. They reinforced the tail for towing gliders. They removed the passenger amenities and turned it into a workhorse. Between 1942 and 1945, Douglas built over 10,000 C-47s. Other factories joined in. A plant in Oklahoma City, another in Long Beach. Even a factory in the Soviet Union built a licensed version called the Lisunov Li-2. By war's end, more than 16,000 DC-3 variants had been built. It became the most produced transport aircraft in history. The C-47 did everything. It dropped paratroopers over Normandy on D-Day. It flew supplies over the hump from India to China, crossing the Himalayas in conditions that would ground almost any other plane. It evacuated wounded soldiers from battlefields. It towed gliders full of troops into combat. It delivered mail, medicine, ammunition, and food to front lines on every continent. Pilots pushed C-47s to their absolute limits. They flew them overloaded. They flew them on one engine. They flew them through flak and fighter attacks. They landed them on dirt strips, beaches, frozen lakes, anywhere with a few hundred feet of flat ground. And they kept flying. Aircraft that took direct hits from anti-aircraft fire limped back to base and were patched up and sent out again the next day. General Dwight Eisenhower called the C-47 one of the 4 most important tools that won the war, alongside the Jeep, the bulldozer, and the atomic bomb. That's how critical it was. After the war ended in 1945, thousands of C-47s suddenly had no military purpose. The U.S. government sold them off cheap. Airlines around the world bought them for pennies on the dollar. Cargo companies grabbed them. Small regional carriers picked them up. The DC-3 got a second life in commercial aviation, and this time it went everywhere. In places like Alaska, the DC-3 became essential. Bush pilots used them to reach remote villages with no roads. They landed on gravel strips, ice runways, and sandbars. One Alaska pilot said, "If you can land a Jeep there, you can land a DC-3 there." The plane's ruggedness made it perfect for harsh environments. In South America, DC-3s opened up the interior. They flew over jungles and mountains where building roads was impossible. Small airlines in Colombia, Peru, and Brazil ran DC-3s on routes that no other plane could handle economically. Some of those routes are still flown today, and some of them are still using DC-3s. In Africa, the story was the same. The DC-3 connected cities and villages across vast distances. It carried everything from passengers to livestock to medical supplies. During famines and emergencies, DC-3s were often the only way to get aid into remote areas. The United Nations used them, the Red Cross used them, missionaries used them. Even as newer, faster, more modern aircraft came along, the DC-3 kept flying. Jets arrived in the 1950s, but jets needed long runways and lots of fuel. The DC-3 could land almost anywhere and sip fuel by comparison. For many routes, especially in developing countries, it just made more sense. By the 1960s, aviation experts kept predicting the DC-3 would finally retire. It was 30 years old by then. Surely it couldn't keep going. But it did. By the 1970s, the predictions continued. By the 1980s, people stopped making predictions. The DC-3 had become immortal. Airlines replaced them, but the planes didn't disappear. They just moved to smaller carriers, cargo operators, and specialty roles. Here's the really wild part. Right now, in 2026, there are still DC-3s flying commercial operations. Not in museums, not at air shows. Actually flying passengers and cargo for money. According to aviation databases, there are roughly 150 to 200 DC-3s still in active service worldwide. In Colombia, Alianza operates DC-3s on scheduled passenger flights to remote regions. These planes were built in the 1940s. They're over 80 years old. They've logged tens of millions of miles. And they're still passing safety inspections and flying daily routes. The company maintains them meticulously, replacing parts, upgrading systems, but the basic airframe, those wings and fuselage that engineers said would fail after 100 flights, are still the originals. In South Africa, a company called Rovos Air keeps several DC-3s flying for tourism and cargo. In Alaska, a few operators still use them for remote supply runs. In Australia, DC-3s fly scenic tours. In Europe, vintage airlines keep them airworthy for special flights and charters. Every continent except Antarctica has at least a few DC-3s still earning their keep. What's remarkable is how well they've held up. Modern inspections using ultrasound and X-ray technology have examined DC-3 airframes that have been flying for 70 or 80 years. Engineers expected to find extensive metal fatigue, cracks spreading through wing spars, corrosion weakening the structure. What they actually found was minimal degradation. The aluminum alloy Douglas chose in 1935 has proven far more durable than anyone predicted. Sure, these planes have been maintained, parts have been replaced, engines have been swapped out multiple times, wiring has been updated, avionics have been modernized. But the core structure, the thing engineers said would fail, hasn't failed. Some DC-3s have logged over 80,000 flight hours. That's nearly 10 years of continuous flying. The original engineers would be stunned. The DC-3 has outlived every aircraft that came after it in the 1930s, 40s, and 50s. It's outlived planes that were supposed to replace it. It's become the aviation equivalent of a vintage car that just refuses to die. So what happened? How did the plane that engineers called a death trap become the safest, most reliable, longest-lasting airliner ever built? The truth is, Douglas got lucky and brilliant at the same time. They over-engineered everything. Not intentionally, they just didn't know exactly how much stress the plane would face, so they built in huge safety margins. Those wings that engineers worried about, they were rated for loads far beyond what normal flying would ever produce. The fuselage structure had redundant supports in places where one would have been enough. The landing gear was built like a tank. Everything about the DC-3 was stronger than it needed to be because Douglas didn't want to take chances. Modern aircraft are designed much more precisely. Engineers use computer simulations and advanced materials to calculate exactly how strong each component needs to be. They minimize weight by minimizing excess strength. It's efficient, but it also means there's less margin for error. The DC-3's crude, overbuilt approach actually gave it longevity that modern planes can't match. The DC-3 also taught the aviation industry that simplicity matters. It had two engines, basic systems, straightforward controls. There wasn't much that could go wrong, and when something did go wrong, it was usually easy to fix. Modern aircraft are far more complex. More complexity means more potential failure points. But maybe the biggest lesson is about predictions. The experts who said the DC-3 would fail weren't stupid. They were using the best information and theories available in 1935. They just didn't account for how conservative and careful Douglas had been. Sometimes the pessimists are wrong. Sometimes the thing everyone doubts turns out to be exactly what the world needs. If you ever get a chance to fly on a DC-3, take it. There aren't many left in passenger service, but feeling that plane lift off, knowing it's been doing this for 80-plus years, knowing engineers once thought it would kill people, there's something incredible about that. The DC-3 proved everyone wrong and then kept proving them wrong for the better part of a century. That's not just good engineering, that's legendary. Thank you for watching. Please like and subscribe, and I'll see you next time.